Have your unit circle available. It says find each value by referring to the graph of the sine or cosine function. Okay, well, we're just going to use the unit circle that we have, so just have this unit circle out. I'll just throw one up here so I can use. And mine won't be completely filled out. Mine will just have a little bit of stuff on it. But really, you'd be surprised just how useful that much of a unit circle is, especially when you graph. Okay, if you just draw this on your paper, life is easy. But you can just go find where to begin and then just rotate around it counterclockwise. Okay, you got to understand that graphing is just rotary motion. So all you're doing is going around a unit circle, and it's going to be displayed two-dimensionally. So that's really all graphing is. So now, ask yourself this question: where is negative pi over 2 located? The 270, right? So what is the cosine value at 270? So your answer here is simply just 0, right? You go locate where negative pi over 2 is, and you can rotate your finger around the unit circle. All you're looking at is for coterminal, right? In the end, mentally, all you're thinking of is, I need to get it between 0 and 360, or 0 and 2 pi, so then I can look at this unit circle. That's all you're doing. That's why it's handy to keep this out all the time when you're working and just get used to it. Pretty soon you will have looked at it so much that you will have it memorized, which you need to have it memorized. Sine of 5 pi over 2. Well, let's write that as a decimal. Okay, so what is 5 halves as a decimal? 2.5. So we're going to do sine of 2.5 pi. So let's go find that on the unit circle. Where's 2.5 at? Okay, where's 2.5 pi? So 2 pi is over at 360, right? So 2.5 pi must be up here where 90 is, isn't it? Or where pi over 2 is, isn't it? Okay. Once you locate it, which one is sine, the x or the y? The y is sine. So your answer is what? 1. Okay, put your calculators in radian mode, please. Mode, if you just reset it, it'll be in radian mode. And put in cosine of a negative pi over 2. Gave us 0, didn't it? And put in sine of 2.5 pi. Gave us 1. Okay, so now do this little unit circle will make your life easier. Okay, remember graphing is just rotary motion in 2 dimensions. Okay, so it's like, imagine you're on your Ferris wheel. Where do I stop? Where's my little car stop? That's all you're doing. Okay, find the values of theta for which sine theta is equal to a negative 1. Where's the first positive place that happens? 270. Okay, so we're going to say 270 plus, how many degrees do you have to go around before it happens again? 360. Okay. Where n is an element of the integers. So it has to be a whole count, right? A whole count of 1, a whole count of negative 1. Okay, let's write that same expression using radians. Okay, you want to always write it in both so you get used to seeing what the radian value is and what the degree value is in the same location. So what's 270 as a radian? 3 pi over 2 plus, and what's 360? So it's 2 pi n. And I'm just going to cheat and draw an arrow up to where n is an element of the integers. Okay? So they asked me find the values, that's plural, right? Okay? And they didn't give me a limitation, did they? So I have to say, like, the rule that would give all of the values forever and ever. All right, these next three will be more involved. We are going to need to graph. Okay, so now we're going to graph the cosine function from 5 pi over 7, from 5 pi to 7 pi. I'm sorry, so we're going to be graphing the positive side. So actually, I'm going to do this. Move, be nice to me. There we go. I need room. Okay. Now, what's your lowest number? 5 pi or 7 pi? Which one's low? 5. Okay, so you always go find the lowest number first. You go find your location, and you do a counterclockwise walk around the unit circle, and it'll give you all the ordered pairs you want, because they're going to go put terminal on it. Okay? So go find me 5 pi. Where's 5 pi on this? What location is it between 0 and 360? It's going to be at pi, isn't it? Okay? So basically, if we drop from pi to 3 pi, really, right? Because isn't the space here, isn't this is just like graphing, pi to 3 pi, except for the x values need to be what? 5 pi to 7 pi, okay? So now, this is going to be 5 pi, this is going to be 7 pi, the middle's going to be what? 6 pi. Now you can write this as decimals or fractions, I'm not going to care. But what's halfway between 5 and 6? 5.5, right? Or 11 pi over 2, right? So you can say it either way, and I'm not going to care, but I'm going to say 11 pi over 2. What's halfway between 6 pi and 7 pi? 13 pi over 2, or 6.5 pi. And remember, you are going to just fold your paper here. You're going to put a crease in your paper like, okay, you know, my graph is extended. I know that, okay, because I'm starting really close with just 5 pi on it. So I'm going to fold my graph paper and say, oop, that means I can start where I want. Now, I'm going to put my 1, 2 spaces up, and I'm going to put my -1, 2 spaces down just for effect. You can just, since you're drawing by hand, you just do your tick marks, right? It's just more pronounced if I do it this way. Now, at pi, what is cosine? It's at -1, isn't it? So that means at 5 pi, I'm going to start at -1. Okay. Now I'm just going to go to my next value for cosine, and it's going to have to be what? It's going to have to be 0, isn't it? Okay. So then that's going to be 11 pi over 2, and that's going to be 0. And then my next stop is going to be 1. Well, I just went from -1 to 0. Now I'm going to 1. Guess what I'm going to do next? Go to 0 and then back to what? -1, right? You're going to draw a smooth curve. Now, they only asked you to draw from that interval, so you don't need arrows on it, right? Because they just said draw from here to here. Go to y here and put in cosine x. Now here we're just going to look at the table. We're not going to look at the picture. Okay? So you're going to have to trust me a little bit on this because it's not going to be 5 pi. It's going to be the decimal equivalent. Okay, what is 5 times pi, right? It's going to be 15 point something probably, right? 15.707. 15.707. Fine. So let's go to our window. Or let's go to our table set. Okay, we're going to start at 5 pi. And we're going to go by pi over 2, right? Isn't that the space we want? So we're going to say 5 pi, and we're going to say pi over 2. That's going to be second pi divided 2. And we're just going to go look at our table. Okay. Now, second graph. Okay. So we end up getting -1, right? And that ugly number is 0. Then back to 1. Then back to 0. And then back to -1, didn't it? So it gave us the same value. Let's make a pretty table. Okay. Let's make a pretty table. Not that thing. So this is x, and this is cosine x, correct? This was 5 pi. This was 11 pi over 2. This was 6 pi. This was 13 pi over 2. And this was 7 pi. And then we said what? -1, 0, 1, 0. That's our pretty table, right? What is 5 pi in degrees? No, I'm saying actually 5 pi. What is 5 pi in degrees? 900, isn't it? So you're going to figure out why they went to radians, because the degrees get way too big, way too fast, right? And if you get used to counting with the radians are real numbers. They like to use them better, you know. So keep that in mind. Okay, so let's go to the next one. And let's do y equals sine x. We're going to do it from -4 pi to a -2 pi. Again, unit circles at the radian. So, we're doing negative, right? So then I need, I'm such a cheater. Not right, that stuff. Okay, so now, locate -4 pi. Where is -4 pi? It's at 0, isn't it? So let's sort of get something, think about it. Your positive x side is your even side, right? And your negative x is your odd side, isn't it? If you think of it that way, it'll sort of make sense. Okay, so basically, when we look at this right here, -4 pi is going to be right here, isn't it? Okay. Which trig function are you graphing? Sine. You're graphing sine, aren't you? So you're going to be looking at the y values all along those ordered pairs. And then you're going to start here. This will be your start point. And then you're just going to do what? Collect your y values around until you get enough. Okay? So we're going from -4 pi to a -2 pi. So that means -4 pi is out here, correct? -2 pi is here. I'm going to fold my paper. What's halfway? Should be -3 pi, should be halfway, right? And then you need what? A -2.5, which is what? A -5 pi over 2. -3.5, which is -7 pi over 2. So we'll say -5 pi over 2, -7 pi over 2. And again, I'm going to do this per now, so this is going to be my 1, and this is going to be my -1. I just want you to see it clearly. let's go ahead and make our pretty table from the beginning. X sine X. Negative 4 pi, we went negative 7 pi over 2, we went negative 3 pi, we went negative 5 pi over 2, and then we go to negative 2 pi. And we are looking at our y values as we go around, correct? So what's the first y value we run into? It should be 0, and then it goes to what?
0 to negative 1.
Then it go looking up here. You're going up. You're going counterclockwise, right? Counterclockwise is a positive move. Okay, so you're going 0, then you're going 1, right? Then you have to do what? Go back through 0 to go to negative 1 to go back to 0, right? Now, I just said this was my first value. I said this was my second value. I said this was my third value. I said this was my fourth value. And then I was back to this one again for my last value. Now, am I right? No. Let's figure it out. Go to y equals, let's do sine. Where are we going to start our table at? We're going to start at negative 4 pi, aren't we? So second window, we're going to start it at negative 4 pi, correct? Now, is 1.57 pi over 2? Yes. So we can leave it there. And just hit second graph and go look at our table and see what our table says. So it started out at 0, didn't it? It went to 1, it went back to 0, it went to negative 1, then it went back to 0, didn't it? Now, negative 6.28 should be negative 2 pi, right? That means that double that, which is up here, negative 12.57, should be a negative 4 pi, shouldn't it? Okay. So we can pretty much trust and believe that to be true, so we can plot our points with confidence. Hold on, I said negative 3 pi over 2. That's just wrong. There we go. So negative 4 pi, negative 3 pi. Gotcha. And you'll see little errors like that, little human errors that you make. You'll see them. And then you draw what? Smooth curve. Do you need arrows? You don't need arrows because they just wanted a closed interval, didn't they? So you don't need it. All right. Now, okay, so now we're going to do tan x from 0 to 2 pi. Tan x gets a little bit different stuff. This particular problem, I'm going to show you how to do it in the calculator, and we'll just get the table from the calculator and the average. Okay. Now, I want you to imagine tangent. Let me take this out here for a second. Tangent, really, when we read tangent, we read this part normally. This gives us our first cycle of tangent. This gives you like your parent function graph, right? From negative 90 to 90, or from negative pi over 2 to pi. Now, tangent's period is 180 degrees, which is half a stage of sine and cosine, right? So that means you need to go every 45 degrees or every pi over 4 to get your points. And this one will have asymptotes. So oftentimes we use this ordered pair, which is root 2 over 2 negative root 2 over 2. And this is we're going to call this negative 45 degrees. And then up here, we're going to do this one, and this is going to be root 2 over 2. And this is going to be root 2 over 2. And this will be 45 degrees, okay? So basically, we are going to use both of these in the ordered pairs for this. Remember, tangent by definition is y over x, right? So you're dividing. So it's better to sort of memorize this table or generate this table in your calculator because you're dealing with two values in your ordered pairs to get these. Okay. So what happens here at, we'll call this negative 90. How about that? What happens here at negative 90? This is going to become what? A negative 1 over 0, correct? It's going to become undefined. So that's going to become an asymptote. We're going to say that's a u. That's undefined there. What's going to happen here when we say negative root 2 over 2 divided by root 2 over 2? What's that going to be? Negative 1. And this is going to be 0 over 1, correct? And that's going to be 0. Now, we're going from negative 1 through 0. We must be going to positive 1, right? Because that order pair is the same, correct? So this will end up being a positive 1. And then we're back to what? We're back to undefined. Okay? So when we know that, we got to understand those asymptotes are going to show up. And we have to deal with it. So 45 degrees is better for you. We're going to do it in degrees first, because I haven't done one in degrees yet, and we'll do it in radians next. Okay? So everybody get your calculator to, let's first do 0 is less than or equal to x is less, let's say it's less than 2, less than 360. We can include as well. No big deal. So that, we're going to go to our calculator, we're going to change our mode. Mode will be what? Degree. Okay. Now, we're going to start our table where? We're going to start it at 0. And we're going to go by 45s. Everything in tangent is separated by 45 degrees. Okay. And then we're just going to hit our table. So second graph, I'm looking at your table. Okay, so table, remember, what's my mode? My mode is degree, right? Second window, 0, 45. Oh, wait a second. Might be nice if I put in the trig function. How about that? That could be helpful, right? Just a TT. Now, let's go and hit second graph. Gives me a pretty nice table, doesn't it? Okay, so let's deal with this. Now, I'm listening. Now I'm going to hit second graph, and we're going to graph this from. Oh, did I pull out a graph chart yet? No, I didn't. Okay, I need to pull out. Here we go. I'm probably going to have to extend my graph a little bit. This is going to be 0 here, 45 here, 90 here, 135, 180. And this will be 225. This will be what, 270. This will be 315. This will be 360. Okay. Now, everywhere you see an error, you draw asymptotes. Okay, so put your asymptotes on your paper first. Make sure you be found. So I'm going to say I got an asymptote at 90. I got an asymptote at 270. Everything in a tangent graph will be 180 degrees apart. All the values in the tangent graph will be 180 degrees apart. So now, at 0, I'm going to plot 0. Correct? And go ahead and put the table on your paper. I'm not going to write the table, but go ahead and put the table on your paper. And really just plotting points. Now, 45, I'm going to just say 1's here this time. So then I'm going to draw that up towards the asymptote. Well, I'm not drawing a full tangent graph there at the beginning. I'm only drawing a partial tangent graph there at the beginning. All right. Now we go to 135. We're going to say this is a -1. So we'll be here. Oh, let's actually put it at 135, shall we? Then we're going to say at 180, we're at 0. And at 225, we are at 1. So then what's going to happen is you're going to disco dance up through these points, tugging the asymptotes. So the tangent function increases from left to right, doesn't it? And then finally, I need to scroll down. And we'll say at 315, I'm at -1. Those 270 got the asymptote. And at 360, I'm back at 0. And so basically, I'm coming up and then I'm stopping there. I don't go. Now, it's important to realize everything with a tangent function, like all the zeros are going to be 180 degrees apart. Okay? All the 1s are going to be 180 degrees apart. Negative ones, 100 degrees, or 180 degrees apart. Oh, here's another 0. Okay. So keep that. I think that's it for the warm-up. So, I'm almost up.